We are learning remainder theorem. So to discuss remainder, we need to talk about division first. So we'll start with division of numbers. 11 divided by 4, we get 2 as a quotient with a remainder of 3. So this can be rewritten as 11 is equal to 4 into 2 plus 3. Now the case of a polynomial getting divided by another polynomial. So to divide this, I will use the long division method. So we have 2x square minus 5x minus 1. So I hope you guys know this. First is you need to write in standard form. Next is take the first term from both the divisor and the dividend. 2x square divided by 1x is 1x. And post that multiply this entire thing. Sorry, this is 2x. So you'll get 2x square minus 3x. So this is nothing but your negative and this is positive and a line. And the answer is 0 and this is minus 2x minus 1. Okay, my bad, this is 6. So plus 1x minus 1. Next is take the term again. First term over here and first term over here. When we divide those two, we'll get 1, right? 1x divided by 1x is 1. So 1 multiplying all of this expression, we will get plus 1x minus 3. So we have, this is minus, this is plus. Get cancelled plus 2. This is your dividend, divisor, quotient and remainder, right? So basically we can write this as 2x plus 1 is what we get with the remainder of 2. So we can rewrite in a similar manner as 2x square minus 5x minus 1 is equal to x minus 3 into the quotient plus the remainder. So in general, we have p of x is equal to d of x, that is your divisor into quotient plus remainder. Okay, if I take this as p of x, this as d of x, quotient and the remainder, we can write in this manner. So this is about division. We still not yet gone to the remainder theorem. But what does the theorem tell? So all this fancy word tells this, that when we divide these two, we got a remainder of 2. So instead of doing such long division, if you are looking for remainder only, you can directly do this. And what is that? Step 1. Look at your divisor. Okay, we have d of x is equal to x minus 3. Find it 0. Finding 0 of d of x. So we have x minus 3 is equal to 0. So x is equal to 3. So this is your 0 of this particular expression. So if step 2 is you substitute this value. So substitute x is equal to 3 in your p of x. So what will we get? In place of x, we are writing 3. So 2 into 3 square minus 5 into 3 minus 1. So this is equal to 9, 18, 15 minus 1. So this is equal to 2. So we got the same remainder, right? So this is what the remainder theorem tells. So instead of doing all the division, you can do this. But there is a condition. And the condition is the divisor has to be a linear equation. Linear expression, sorry. Okay. So let's read the statement. If let p of x be a polynomial of degree greater than or equal to 1 and let a be a real number, If p of x is divided by a linear polynomial, then the remainder is given by p of a. Okay, so a is the same a over here and here and over here. So in this case, a over here is 3. So in this particular example, a is 3. That's it. That's all the remainder theorem tells. So in general, if you want to write the steps, write the expression in standard form, find the 0 of the divisor, substitute in the dividend. So these are your steps. Okay. Extended form of this particular theorem is your factor theorem. So factor theorem talks about this. If we do the division and end of it, the remainder happens to be 0, then the one which divided is a factor of the polynomial. I'll explain it this way. If I happen to divide 120 with 4, obviously you guys know for sure that the remainder is 0. So what can you tell about 4 and 120? 4 is a factor of 120. This is one of the conclusions. So if we happen to get a remainder of 0, obviously the one which is dividing is a factor of the one which is getting divided. So dividend, divisor, quotient, remainder, right? Dividend, divisor, quotient and remainder. So it's quite simple. It's logical also. So it's not complicated. So I thought I'll introduce here itself. So now you guys have to pause and copy this off. Lot to copy, but yes, it's going to be useful.